Space. It looks like a peaceful, well-ordered clock. Every planet has its place, orbiting the sun in a predictable dance that has lasted for billions of years. But if we look closer at the inner solar system, we find something wrong. A cosmic crime scene where the evidence just doesn't add up. The problem is Mars. According to every computer simulation of how our solar system formed, Mars shouldn't be a tiny, frozen desert. It should be much bigger, about the size of Earth or Venus. Instead, it's a puny 10% of Earth's mass. A developmental runt. To find out why, we have to go back 4.5 billion years, to the very beginning, the protoplanetary disk. A chaotic soup of gas and dust. In this chaos, the first giant was born. Jupiter. And its birth would change the fate of every other planet forever. Jupiter grew fast. Within just a few million years, it became the heavyweight champion, gorging itself on the surrounding gas. But there was a problem. In a disk full of gas, a massive planet doesn't just stay put. It creates waves, and those waves push back. This is called gas-driven migration. Friction with the disk acts like a cosmic brake, causing the giant planet to spiral inward. Jupiter wasn't just moving, it was heading straight for the inner solar system. The very place where Earth was trying to form. At this time, Mars and Earth were just planetesimals, small planet seeds. And a wandering Jupiter was the ultimate wrecking ball. As Jupiter migrated inward to where Mars sits today, it acted like a giant gravitational vacuum, swallowing the material needed for a big Mars. This is why Mars is so small. Jupiter robbed its neighborhood of all its building blocks, leaving Mars with nothing but scraps. Jupiter had reached $1.50, the current orbit of Mars. If it kept going, it would have plowed right through the orbits of Earth and Venus. In most other systems, giant planets keep going, becoming hot Jupiters. So, why did ours stop? Jupiter was spiraling inward, a wrecking ball destined to clear the inner system. But it wasn't the only giant being born in the cold outer reaches. Meet Saturn. Born a bit later and a bit smaller, Saturn was also caught in the same gas-driven slide toward the Sun. Just like Jupiter, Saturn was being pushed inward by the gas disk. Two giants, both falling toward the inner solar system at different speeds. Because Jupiter was more massive, it moved faster at first. But as Saturn grew, it began to gain on its bigger brother. Then, the impossible happened. The two giants entered a gravitational lock called a mean motion resonance. Specifically, a 2-to-3 resonance. For every 3 orbits Jupiter made, Saturn made exactly 2. They were now perfectly in sync. This changed the physics of the disk. Instead of falling in, the two planets began a gravitational tug-of-war against the gas. The combined mass of Jupiter and Saturn cleared a massive gap in the gas disk. And then, they tacked like a sailboat turning into the wind.
As
Jupiter's inward spiral didn't just stop. It reversed. The giant began to migrate outward, away from the Sun and the inner planets. This was Earth's lucky break. If Saturn hadn't caught Jupiter at exactly $1.5, Jupiter would have kept going until Earth was swallowed or ejected. But Jupiter wasn't done reshaping our world. On its way back out, it plowed through the outer disk, scattering icy rocks everywhere. Some of these icy rocks were flung into the inner solar system, crashing into the young, dry Earth. This might be how we got our water. So, next time you drink a glass of water, remember, it was likely hand-delivered by a rampaging gas giant billions of years ago. Jupiter and Saturn finally settled into their modern orbits, leaving behind a scarred but stabilized solar system. Earth was safe. But we were lucky. Across the galaxy, most Earths aren't so fortunate. Why is our system so different? For 500 million years after the Grand Tack, the solar system seemed to settle down. But this was just the calm before a second, much bigger storm. Back then, the 4 giant planets lived in a very crowded neighborhood, packed much closer together than they are today. Beyond them sat a massive ring of frozen leftovers, the Proto-Kuiper belt. Trillions of icy rocks waiting for a nudge. Gravity is a game of balance. Every time a giant planet kicked an icy rock, the planet itself moved a tiny bit in the opposite direction. Slowly, Jupiter drifted in, while Saturn, Uranus, and Neptune drifted out. Until they hit the ultimate tipping point. The 1-to-2 resonance. For every 1 orbit of Saturn, Jupiter did exactly 2. This triggered a gravitational explosion. Jupiter and Saturn kicked each other with such force that the entire solar system lost its mind. It was planetary musical chairs. Uranus and Neptune were tossed like toys, flying outward and plowing straight into that ring of icy rocks. The icy belt didn't just move, and it shattered. Billions of comets were sent screaming into the inner system from every direction. This is the late heavy bombardment. A time when the planets were literally being pelted by space ice and rock for millions of years. Just look at the moon. Every single crater you see today is a scar from this violent planetary shuffle. Some theories even suggest there was a 5th giant planet, a sibling of Neptune, that was kicked out of the solar system entirely. Neptune ended up as the new outer sentinel, settling into a cold, dark orbit 4.5 billion kilometers from the Sun. Finally, the chaos stopped. The planets reached the stable orbits we know today. The giant game of musical chairs was over. The solar system we see now is just the wreckage of a much more violent past. A masterpiece built on a foundation of chaos. While the giants were playing musical chairs, the inner planets were dealing with their own nightmare. 4.5 billion years ago, Earth was a hellscape. No oceans. No oxygen. Just a sea of liquid rock. But Earth was about to get a visitor that would change it forever. This is Theia. A Mars-sized planet that shared an orbit with Earth. And they were on a collision course. Scientists call this the giant impact hypothesis. It wasn't a head-on crash, but a devastating, glancing blow. When they hit, the energy released was enough to melt both planets completely. It was the ultimate cosmic car crash. Theia was destroyed. A massive amount of debris was blasted into orbit, forming a ring of glowing liquid rock around Earth. In just a few short years, an eye blink in cosmic time, gravity pulled that ring together. Like a celestial cotton candy machine. And there it was. The moon. Born from the wreckage of Earth's own body and the corpse of a dead planet. At first, the moon was 15 times closer than it is today. It loomed massive in the sky, causing Earth's magma to bulge. The tides weren't water, they were tides of lava, 20 kilometers high, surging every few hours as Earth spun much faster. A day on early Earth lasted only 6 hours. But the moon's gravity acted like a brake, slowing Earth's rotation down over billions of years. Without the moon, Earth would wobble wildly, causing extreme climate shifts. The moon is our gravitational anchor. As Earth cooled and water finally settled, the moon's tides helped stir the chemical soup of our early oceans, setting the stage for life. So, the moon isn't just a pretty light. It's a piece of us. A sibling born of fire that keeps us steady in the dark. But did the impact leave something else behind? Something hidden deep inside Earth's core? Let's find out. To understand why Earth is alive and Mars is a desert, we have to go down. Way down. 6,000 kilometers beneath your feet. Beneath the crust lies the mantle, a thick layer of hot, plastic rock. But at the center lies the engine room, the core. The inner core is a solid ball of iron and nickel, as hot as the surface of the sun, about 6,000 degrees Celsius. Remember Theia? Scientists believe the dense iron cores of Earth and Theia merged during the impact, giving us an oversized, hyperactive heart. The outer core is liquid. As Earth spins, this liquid metal swirls like a giant blender, creating the dynamo effect. This movement generates a massive electric current, which in turn creates Earth's most important defense, the magnetic field. The magnetosphere. An invisible shield that stretches thousands of kilometers into space, protecting us from the solar wind. The sun is constantly blasting out high-energy particles. Without our shield, this wind would strip away our atmosphere. It's like a cosmic umbrella. It keeps the atmosphere from being sandblasted into the void of space. Just look at Mars. Mars lost its magnetic field billions of years ago. Today, it's a barren husk because its air was stolen by the sun. Sometimes, the shield lets a little bit of the sun in at the poles. We call this the aurora. A beautiful reminder that our shield is working. But the shield isn't permanent. The magnetic poles are always moving, and every few 100,000 years, they flip. During a flip, the shield weakens, leaving us slightly more exposed. But don't worry, life on Earth has survived hundreds of these. As long as our iron heart is hot and spinning, we stay safe. Earth's core is the unsung hero of our cosmic story. But what happens when the sun itself starts to change? In the far future, our shield won't be enough. Let's look into the end. For 5 billion years, the sun has been a perfect host. But stars, like everything else, have a lifespan. And ours is halfway through. As the sun burns through its hydrogen fuel, it gets slightly brighter and hotter, about 10% more every billion years. In just 1 billion years, long before the sun actually dies, Earth will become too hot for liquid water. Our oceans will simply evaporate. Then comes the crisis. Around 5 billion years from now, the sun runs out of hydrogen. It begins to swell into a red giant. The sun will expand to over 200 times its current size. It will become a monster that fills the entire sky. Mercury is the first to go. It is simply swallowed whole by the outer layers of the sun's atmosphere. Gone in an instant. Venus is next. Already the hottest planet, it now literally melts before being consumed by the expanding star. For Earth, the debate is still out. The sun will expand almost exactly to Earth's orbit. We might be swallowed, or just fried to a crisp. But as the inner system burns, the Goldilocks zone moves outward. The frozen moons of the outer giants finally get their turn. Jupiter's moon Europa will melt, its global ice shell becoming a vast, warm ocean under a massive red sun. For a few 100 million years, the edge of the solar system will be the new tropical paradise. A brief second summer. But the red giant phase is unstable. The sun will eventually puff out its outer layers into space, forming a beautiful planetary nebula. A ghost of its former self. A glowing tomb of gas that will float through the galaxy for thousands of years. At the center, all that remains is a white dwarf. The size of Earth, but with the mass of a star. A cold, diamond-like ember. Our sun is lucky to go out so peacefully. But some stars are so massive, their death breaks the universe itself. Ready for the monsters? While our sun is a peaceful yellow dwarf, some stars are monsters. Blue supergiants, tens of times more massive, living fast and dying hard. Inside, these stars are element factories. They fuse hydrogen into helium, then carbon, neon, and oxygen. But then they hit a wall, iron. Fusing iron consumes energy instead of creating it. The star's engine suddenly stalls. Gravity wins the billion-year tug-of-war. In less than a second, the core collapses, and the rest of the star bounces off it in a supernova. The brightest explosion in the universe. This explosion creates every heavy element, gold, silver, the iron in your blood. You are literally made of dead stars. But if the core that's left behind is heavy enough, gravity doesn't stop. It crushes the core into something impossible. A black hole. A region where gravity is so strong that not even light can escape. It is a hole in the fabric of reality. This is the event horizon. The point of no return. Cross this line, and the laws of physics as we know them break down. If you fell in, you'd experience spaghettification. Gravity at your feet would be so much stronger than at your head that you'd stretch into a noodle. Time also breaks. From the outside, you would appear to slow down and freeze at the edge, while for you, time would pass normally. At the very center is the singularity. A point of infinite density where space and time simply end. Our math can't go any further. Most galaxies have a supermassive black hole at their center.
Millions of times
Ours
the
is
mass of
Sagittarius
our
A*, 4,000,000 times heavier than our Sun. Are they portals to other universes? Are they the key to the theory of everything? We still don't know for sure. Black holes aren't just destroyers. By anchoring galaxies, they are essential to the structure of the universe itself. We've seen the birth, the life, and the death of stars. But what happens to the whole universe when the lights finally go out? To truly understand the 100 million year chaos, we need to talk about scale. If the sun were the size of a soccer ball, Earth would be a tiny grain of sand, located about 27 meters away. That's roughly the length of 2 school buses. Jupiter, that would be a cherry tomato, sitting nearly 140 meters away, about 1.5 football fields from our soccer ball sun. And Pluto? A microscopic speck of dust, over a kilometer away. The solar system is mostly just empty space. But remember, the original nebula was thousands of times larger than this. Most of that material was lost to the stars. Now look at the time. If the history of our system was a 24-hour clock, the 100 million year chaos happened in the first 30 minutes. Life didn't even show up until mid-afternoon. And humans? We only appeared in the very last second before midnight. Every atom in that last second was forged in the chaos of that first half hour. You are ancient history, walking around. We owe our lives to the bullies like Jupiter that moved at just the right time, and the collisions that gave us our moon. Our home is a masterpiece of physics, built from the wreckage of a violent past. And it's the only one we've got. So take a moment to look up tonight. You aren't just looking at the stars. You're looking at your origin story. The chaos is over for now. But the universe is still building.